Okay, so solving equations via inverse operations. This is the method that we're going to use algebraically to solve all equations. So the first question I have is, what operations are inverses of one another? All right. So see if you can think of operations that are inverses of one another. Okay, so I think that's definitely right. Addition and subtraction. Are inverses of one another. And multiplication and division are inverses of one another. There we go. Catch up. Very good. And if we think back to the inverse property, right? The inverse property said that any number plus its opposite, or if you subtract that same number, right? So we know that 3, let's see, can we get a pen working? So if we have 3 plus negative 3, we know that that's 0. And that was part of the inverse property of addition. Any number plus its opposite equals 0. Or if we just say 3 minus 3, right, equals 0. And this comes to my other point. And my other point is that, right, subtraction is the same as adding the opposite. We know that. Boy, this is really have an issue. Okay. And multiplication and division are inverses of one another. Okay, so they undo. If we think of the inverse property for multiplication, be any number times its reciprocal is equal to 1. So 3 times 1/3 is equal to 1, and 3 divided by 3. All right, if we divide it by itself, we also get 1. So again, division is the same as multiplying by the reciprocal, and subtraction is really just the same as adding its opposite. And so we know this from last year, maybe even the year before. We've got a simple two-step equation here. We're going to solve for x, and to do that, right, we think about what's happening to x. X is being multiplied by 3 and added by 4. So inversely, we're going to do the opposite. We're going to do the inverse of adding 4, and that's subtracting 4 to both sides. Now look over here on the right. That's the subtraction property of equality, or SPOE, SPO for short. It says that if you subtract the same number from both sides, they will still be equal. All right, subtracting equal numbers from equal expressions, the results will be equal. So in other words, if you subtract 4 from both sides of the equal sign, you're good. Okay, and that would give me on the left side, because plus 4 and minus 4 is 0, this turns into 3x plus 0. All right, which is 3x. 3x plus 0 equals 3x. That's the identity property of addition. And in case you're wondering, 31 minus 4 is 27. Okay. Duh, Mr. Bossert. Okay. And then to solve that, we know that we're going to have to go ahead and divide both sides by 3. And since I'm dividing both sides by 3, that's the division property of equality. All right. So we've got a couple new properties in here. If we're doing the same thing to both sides of an equation, that's a property of equality. All right. We know that the reason that we want to divide by 3 is because it's the inverse of times by 3. And, you know, it doesn't turn into 0. It turns into 3 divided by 3 is 1x. So this turns into 1x, which we know by the identity property then just turns into 1 times x is x. And that's the identity of multiplication. Alright. I got any other fun tricks down here? No. I want to draw your attention to over here on the left. Okay, I've got my order of operations, PEMDAS again, and that's the order that I simplify, right, parentheses, then exponents, and multiplication, division, addition, and subtraction. I'm actually going to solve equations, right, in the exact opposite or inverse way. I would undo any addition and subtraction first. So thinking back to up here in red, I undid the plus 4 first by subtracting 4. I did the inverse property and got that done. And then it was 3x equals 27. So I did the inverse 3 times x. The inverse would be divided by 3 to both sides. And so I undid the multiplication by dividing, and then I was left with the answer. It might be that I have to undo an exponent or undo a parentheses. Now I've got this really funny guy here. Alright, you can pretend that's me. But to think about where this guy is when we start this equation, alright, there's no parentheses to do. Let's go back up to the top. There's no parentheses to do. There's no multiplication I can do because 3 times x is 3x. There's no addition and subtraction to do. So there's nothing to do. When I say do, I'm talking about simplifying the left side or the right side. And so really, this guy is kind of not going down the stairs, he's going back up the stairs. He's now ready to undo in inverse order. So undo the addition of 4 by subtracting 4, then undo the times 3 by dividing by 3, and then we get our answer. Okay, so where's the guy here? Well, again, the simplifying guy, you can just slide all the way down to the bottom because there's no simplifying to do on the left side or the right side. Okay, everything is simplified. There's nothing to do over here and nothing to do over here. Now I'm ready to undo. Okay, so I'm going to undo, now hop back up the stairs, undo any addition or subtraction. This minus 32, the inverse of that would be to plus 32. So let's do that to both sides. And that would leave me with negative 8y minus 32 plus 32. That's 0. Jeez. What's over here? 80. Good. And negative 8y plus 0, the identity property says that that's just negative 8y. Gotta get that sorted out. And then it's negative 8 times y, so the inverse of that, let's get our guy. Hop back up. Now I'm going to undo multiplication and division. So I need to divide both sides by the inverse of timesing negative 8 would be divide by negative 8. So I'm going to divide by negative 8. And that gives me 1y, or y over here, and negative 10 over here. Sweet! Okay. Now, where's my guy over here? Where does he start? Can he slide all the way down to the bottom? Is there any simplifying to do? If there's none, then he slides down to the bottom. And that's not the case here, right? We've got parentheses. But if we look in the parentheses, you can't do any of this. 3x minus 6 you cannot do because they're not like terms. And there's no exponents. So there's multiplication and division to do. Yes, we've got the distributive property. And often that's where we will start, right? So I'm going to distribute the 2 into both of those and simplify that to be 6x minus 12. And now if we take a look at our guy, there's no adding and subtracting to do because I can't do 6x minus 12. So now I'm down here at the bottom and I'm ready to undo. So undo the minus 12 by plus 12. Sorry about that. And that gives me 6x plus 0, which I know is going to just turn into 6x. So I'm kind of shortcutting it there, and that's okay. And 46. And I'm going to divide both sides by 6. Why? Because it's the inverse of timesing by 6. That would give me 1x, or x. And then 46 divided by 6. Oh no! That's going to not come out evenly. What do I do? Well, we do it. Now, 46 divided by 6, anybody know what that is? You might. Okay, there might be some people in here that can tell us whatever it is, 7.6 repeating. If you have it, you're going to like this. If you have a division you don't want to do, are you ready? The Bossert rule is don't do it. Don't do a division you don't want to do. We're going to maybe change this into a mixed number or reduce the fraction. It turns into 23 over 3, which we know is then going to turn into 7 2/3. Come down here. Sorry about that. Did I write? There we go. Try this again. 7 2/3. Close enough. Alright, which you probably know the decimal is 7.6 repeating. Alright, I want you to do this one on your own. Hit pause. And then when you're done, hit unpause, hit play, and then we'll talk about what happened. Okay, we probably see that. Alright, the guy, my little guy here. Come on, guy. Hello. There he is. He doesn't want to move. He's stuck. He's very disappointed. He's disappointed with life. He keeps falling down. Oh no, that's horrible. Okay, well, I don't like him very much. We know that, alright, simplifying this one, how about purple? That sounds good. I need to undo addition and subtraction first, but this is a trick, right? It's not minus 14 here, right? This is 14 is positive, so the inverse of that really is negative or minus 14. So this is a little bit of a trick. The minus sign is there, but the minus sign controls the 12y. It does not control the 14. So the inverse of positive 14 is negative 14. So this becomes 0 minus 12y, which is negative 12y. So the left side turns into negative 12y. The right side is negative 44. And so divide by negative 12 to both sides. Y equals, yikes. Not sure why it's doing this. This will turn into 3 and so again, negative divided by negative is going to be positive, and then 12 into 44, it goes 3 times with 8/12, so it's going to be 3 8/12, which turns into 3 2/3. It's exciting. Is it 8/12? 36, 8, yeah, that sounds good. Alright, so 3 2/3 positive. Very good. Nicely done. Hopefully you did a great job with that. Alright, now you're ready to solve simplifying and then solving.